Good morning, friends. We have discussed center of mass and the concept of center of mass. Also, we solved some problems related to the center of mass. Now, we are going to extend this topic to motion of center of mass. It is 7.3. It's 7.3 motion of center of mass. Let's see. Now, the rigid body or extended body is a collection of particles or any object which is a system of particles we consider to it. And if suppose the body consists n number of particles of masses m1, m2, m3, so on mn, which are at a distance r1, r2, r3, so on rn from axis of rotation. This is any rigid body we consider. This is its axis of rotation m1, m2, m3, m4, mn. These are the distances r1, r2, r3, r4, rn. There are these distances from the axis of rotation. In this case, we have defined center of mass as, so R is the center of mass, which is given as summation mi ri, I goes from 1 to n, divided by summation mi, I goes from 1 to n. This summation mi, I goes from 1 to n is equal to capital M. Therefore, R is equal to m1 r1, m2 r2 plus mn rn divided by capital M. Then we get it, that is mr is equal to m1 r1 plus m2 r2 so on mn rn. Mass, it's a total mass, sum of mass of all the particles is equal to m1 r1, it is equal to m1 r1 first particle, m2 r2 second particle, mn rn nth particle. Now we differentiate. M is constant, dr by dt. This is the differentiation with respect to time. Change in r divided by change in time. We differentiate this one, which is equal to m1 is again taken as a constant t plus m2 dr2 divided by dt. M is constant, so it does not change, so we cannot differentiate it. M is constant. R1 is changing, so dr with respect to dt, so that is dr1 by dt. It is called as a derivative. Same way we can write it as mn drn by dt. mn drn by dt. We go on differentiating and it becomes. So dr by dt, it is nothing but velocity of center of mass. It's a position vector of center of mass, therefore its a differentiation is a velocity of center of mass, which is equal to m1 v1 velocity of first particle, which is equal to m2 v2 velocity of second particle, mn vn velocity of nth particle. So m velocity of center of mass, which is equal to m1 v1 velocity of first particle, m2 mass of second particle, velocity of second particle, and so on. Again we differentiate this one, that is m dv by dt. This is center of mass. This one we are taking capital M as center of mass, which is equal to m1 dr1 dv1 by dt plus m2 dv2 by dt plus so on mn dvn by dt. mn dvn by dt, etc. So on. We get it. dv by dt is acceleration of center of mass. ma, mass into acceleration of center of mass. m1 a1, acceleration on first particle. m1 a1 plus m2 a2 and so on mn an. It means that mass into acceleration, it is the force on center of mass. This is ma, we write it as it is. This is force on first particle. This is force on second particle. So on. It is force of nth particle. When I say F1, there are two things. Whenever I am saying F1, it is the force on first particle. In that one, there are external forces and there are internal forces. We all know internal forces appear in pairs and they cancel out each other. Even though internally the forces are acting on the particle, net force due to internal forces is zero. And therefore, it is only external force, but it's a summation of all external force. F1, when I say, it is a summation of all forces. There are, even though more than one forces are acting, it is a summation of them. Therefore, we get it. Ma is equal to summation of all external forces. It is only external forces. Internal forces do not act on it. And therefore, all external forces on all particles, what they do? They produce acceleration on center of mass. Therefore, center of mass is accelerated due to external force. Or other way around, we can say, we can come to the definition of this center of mass. That is, all other particles we do not consider. Here now at this stage, only center of mass we are considering. Remaining one, we sum them up in all external forces. When different external forces are applied on different particles of the body, the effect of that one is that it accelerates center of mass, and this acceleration plus sum total of mass of all the particles, it gives you external force, and it is a basically definition of center of mass. It means that it became 1 point, body became 1 point, and even though forces are acting at different particles, we consider them as if they are acting at 1 point. That point is the center of mass, and this gives us a definition of center of mass. Center of mass is a point where the whole mass of the body is supposed to be concentrated in order to study its motion in accordance with Newton's laws of motion. Here it is only external force and no internal force. Now let us consider one example. See that the projectile, already we have studied. If the projectile is projected, what happens to that projectile? Projectile follows parabolic path. It goes in this way. Projectile is going parabolic. In this one, it's an extended body. It is a system of body. Therefore, what is going along this projectile path? It's a center of mass. This point, it's a center of mass. Even though this is the body and this is the center of mass. What is moving along the projectile? It's a center of mass. It's a center of mass. It's a center of mass. So remaining body, it may perform rotational motion also. But the center of mass is moving along the projectile as if it is a single particle. Now, if in between, suppose this is exploded, this one is exploded due to internal forces, it's exploded, and its different particles are just scattered in the surrounding, then what happens? The next course of this motion, after this also, even though it is scattered in hundreds of particles, the center of mass of all these particles, this system, it is not the center of mass of this body now. It is the center of mass of all these scattered particles. It moves along projectile. Please understand the difference. Because here internal forces do not matter. Internal forces only explode the body. Its explosion took place, but after explosion, the particles which scattered in the surrounding, their center of mass moves along this projectile path. It moves along this path. Up to this one, it was the body moving along the projectile. But hereafter, it's a center of mass of all these particles. It moves there. In this complete process, we consider this body. It may be performing purely translational motion. It may be performing translational plus rotational motion, or it may be rotational also. We do not consider any internal force. We only consider external force, and this is the motion of center of mass under the action of external force. That's all. Thank you.